My name is Charlie Eisler,
And my name is Tiffany Klontz.
and this is our Civil Engineering 160 project on bridge cost versus year. So on this table of contents, it is showing who's going to speak on each slide and also each point of our PowerPoint.
Charlie and I are both engineering majors, so we wanted to do our project on an issue related to engineering. We both realized that we have an affection for the built environment and decided that bridges would be an interesting topic to focus our project on. After doing extensive research, we discovered data on the cost of bridges as well as the total number and total area of bridges for each state. From here, we decided to focus in on California. Then we analyzed this data and came to a conclusion which will be presented later in this video.
Okay, so we both decided that bridges would be a good point to focus on, and then after doing some research, we came across multiple articles on the Bay Bridge in Northern California. So when the Bay Bridge was first built in the 1930s, they were able to build it ahead of schedule in just 5.5 years and also under budget at $78 million. Since this bridge was built at the peak of the Great Depression, the jobs and people available were paramount compared to today. Therefore, decades later, as the bridge needs repair after earthquakes and other environmental forces, the cost and time it will take to fix the Bay Bridge have skyrocketed. With time also comes more safety and environmental regulations that have come into effect, which also adds on to the time and cost of building such a great bridge. Figuring out what the new span will look like has taken up to 5 years to this day, and the expected time for completion is twice the amount of the first time, and the cost is 4.5 times larger at $6.4 billion. So after reading this article, we decided we wanted to do more research on the cost of bridges over time and how they have managed to grow at such alarming rates.
Across data on the U.S. Department of Transportation Federal Highway Administration's website regarding bridges. We compiled this data into a table shown here. This table is showing the total number of structurally deficient National Highway System bridges in California, the total area of these bridges, the estimated total cost of these bridges assuming replacement, and the estimated total cost assuming rehabilitation, which implies 60% of the total replacement cost. From this data, we calculated the average cost per bridge assuming replacement, as well as the average cost per bridge assuming rehabilitation. This data is for the years 2013 to 2016.
Okay, so from data given to us by the U.S. Department of Transportation Federal Highway Administration, we were able to find the cost per square meter of federal aid highway bridges versus the year that they were built. And as you can tell, besides a spike in 2006, that the cost of the bridges have been steadily increasing since 1994. And we got the 1994 to 2011 data from the Department of Transportation, and then from 2012 to 2016, we were able to calculate that using our own data.
Using the data shown in the table shown previously on this PowerPoint, we created a graph portraying the total number of structurally deficient bridges in California versus year from the years 2013 to 2016. As you could see, the number of these bridges has been steadily decreasing throughout these years.
For this graph of the estimated total cost of total number of structurally deficient NHS bridges in California versus a year, we came up with this graph, and the top line is showing the total cost of replacement of total bridges, and then the bottom is showing the total cost of rehabilitation of total number of bridges. And you can see that it is steadily decreasing as the years go on.
The data shown in the last two graphs, we calculated the average cost per bridge in California versus the year, which is shown in this graph here. Although the total number of bridges as well as the total cost of bridges has been decreasing throughout these years, the average cost per bridge has been steadily increasing throughout the years 2013 to 2016, which is shown here.
So on this graph, we have the cost per square meter of federal aid highway bridges in California versus the year. And we decided to use this graph for our probabilistic modeling because this graph showed the largest range of data from 1994 to 2016.
In order to do our probabilistic modeling, we generated 1,000 random numbers between 1989 and 2021 in order to simulate plus and minus 5 years outside of our data range, shown on the previous slide. From the equation of the line and the r-squared value of the graph shown on the previous slide, we generated a model of the cost per square meter of federal aid highway bridges in California from 1989 to 21.
Okay, so from the previous graph, we then decided to use the same equation, which is an inverse normal distribution, and put in for every random number, we would put in each year, so either 2017, 2018, 2019, or 2020. And from there, we were able to predict the cost per square meter, which would be the average. And then we also were able to find the standard deviation, which is all seen in this graph.
We were able to come up with a couple of conclusions from the data and the research shown in this PowerPoint. So, as you saw, we generated a graph of the estimated cost per square meter of highway bridges in California with plus and minus 5 years outside of the data range provided to us. And we use this to predict the cost per square meter of these bridges 4 years into the future, from 2017 to 2020. What we found was that this cost is steadily increasing despite the fact that the total number of bridges in California has been decreasing from 2013 to 2016. We hypothesized that the reason why the number of bridges is decreasing is because of the fact that the cost of these bridges is constantly increasing.
So that's the end of our presentation. Thank you for listening.
There we go.